So friends, colleagues, students and visitors, welcome to the Melbourne School of Design Dean's Lecture Series. Our series aims to connect the Melbourne community with international leaders in built environment fields, so we may gain inspiration and deeper understanding of our fields from the best of international practice. My name's Julie Willis and I'm the Dean of the Faculty of Architecture, Building and Planning. And I begin this morning's proceedings by acknowledging the traditional owners of the lands on which we meet today, who have been and remain the custodians of these lands. Today, of course, we are connecting with each other online and many of us joining from different parts of Australia. So I acknowledge that all these lands are places of age-old ceremonies, of celebration, initiation and renewal, and that traditional owners have had and continue to have a unique role in the life of these lands. I pay my respects to their elders and families, past, present and emerging. This is our first lecture in the Dean's Lecture Series for 2021, and I'm so pleased to welcome you to this year's program. We're absolutely thrilled to have Lisa Iwamoto with us today. Lisa is a founder of the globally respected practice IwamotoScott Architecture and is a recipient of the Architectural Record 2018 Women in Architecture Award. She is currently Professor of Architecture at the University of California, Berkeley, where she was named the inaugural Doris and Clarence Malo Collegium Teaching Chair in Design, and where her design research concentrates on the perceptual performance of material and digital fabrication techniques. She has taught previously at the University of Michigan, where she was a Muschensheim Fellow, Harvard University, Cornell University, the University of Sydney, and Southern California Institute of Architecture. Lisa was invited by members of our new ADDF Research Hub because, like our hub group, she has a multifaceted career as an architect and academic, designing small-scale experimental pavilions, interiors, as well as large projects. Her practice looks at the intersections among the conceptual themes that bind her works, such as spatial principles, material quality, to achieve unique design responses that are silently innovative. My colleague, Professor Donald Bates, Associate Dean Engagement, will provide closing remarks at the end of today's event because unfortunately I have to race off to another one. So I will now hand over to Lisa, and thank you so much for joining us here in Melbourne today.
Thank you so much. I would really like to thank Dean Willis, as well as Sofia Colabella and Alberto Pugnale for this wonderful invitation. It's a pleasure to be here, and when I say here, I mean here, be able to present to you because I'm actually sitting at my dining room table. And what you're seeing is a background photograph of my office, which I have not been in for a year. But it's really wonderful to speak to an architectural community, especially one in Melbourne. So with that, I would like to share my screen. Thank you for the wonderful introduction. As Julie mentioned, our work does center on a range of experiments at various different scales. Our office really began at the one-to-one scale of installations. And the work ranges from anything as small as a furniture scale prototype to something as large as a speculative design as a city. And being academics, Craig and I, Craig Scott, who is my partner, focused on the two outer edges first. With the installations, it was really a chance for us to experiment at one-to-one scale with material explorations. And at the far spectrum, with the speculations, a chance for us to work with processes that we wouldn't normally be able to do in our practice, and also to look at the urban scale, which we have yet to have been able to do in our practice. And then those two scales bridge in the middle with buildings and interiors, which we've been doing more recently with building our bricks and mortar practice. And so really, this is sort of a talk about our office, which feels like it's in a perpetual state of transition, but particularly now, where the two more experimental ends are meeting in the middle. So with that, I've culled the group of projects quite a bit for the sake of time, but also rearranged them for some conceptual clarity, and then added some more recent projects in, as well as some things that we have on the boards. So with that, I'd like to begin first with the installation scale And here for us, really, I mean, we're very much inspired by conceptual and abstract art, which is shown here at the top. So I believe you can see my cursor. And the idea for us is that this is a Ava Hesse piece and Antony Gormley. And the idea of how can multiple parts come together to create a more synthetic whole? And how can that whole give a kind of perceptual performance that the parts in and of themselves might not have? And then there's a Tara Donovan styrofoam cut piece here, and then actually just a tire ballast over some hay bales in the Midwest. But also the idea is how can ordinary materials be transformed and defamiliarized through the way that they're brought together? And so our installation work really kind of was twofold. On one hand, we were looking at how to make thin materials volumetric and how to think about creating structure through geometry. I have a structural engineering background prior to becoming an architect, and while I was not a very good structural engineer, I feel that that experience during that time has now folded into our practice in a way that is very tangible in how to think about materials yet in different ways. And then the other side of our material explorations just had to do with how can we take something which is quite ordinary again and turn it into something that is perceptually more performative than the original piece itself. So I'd actually like to speak just to one installation project, which is a culmination of a series of work that we did looking at this really thin paper material. It's actually a actual wood product laminated onto a paper, long fiber paper, so that it is foldable. And what we were interested in here is how to think about folding along the curved edge so that the material can gain structure and also have a geometric deformation because of that curvature. We had been doing folding along straight edges for quite a while, and I have an interest in origami ever since I was very little. So this was a kind of natural extension of that. And just wanting to think about what happens when one folds along a curved seam. The one thing that this slide also represents is that we tend to work a lot with our hands on the installation scaled work. So while ultimately the project needed to move into a digital milieu in order to be built and constructed because there are a number of unique parts, what we really began with and often begin with is just, what can this paper do? How can we take something really simple and flexible and turn it into something more rigid, which is what we did here with these handmade models. One of the things that we were really delighted by, I suppose, with folding along a curved seam is that it has an implication of the module in section as well as in plan. And so what we begin to discover by aggregating these pieces together, and sometimes the modules had 3 curved edges, other times they had 1 or even 0 curved edges, is that the way that the modules are packed together had a great influence on their structural abilities. In other words, the closer they were together, the more structural the overall form became, and the less they were packed together, the less structural the form became. And so this is where the kind of conceptual clarity of the project, I would say, came together. So, we were making little handmade models for a number of weeks without really knowing what we were doing. And it was only as we started to assemble them in greater parts that we began to realize that what we were trying to achieve is a kind of mashup, if you will, of 2 structural paradigms. One being the idea of the arch, which is a pure compressive element, and the other is the idea of this very thin catenary member, which has almost 0 stresses. So how can we fold those things together to have the ultra lightweight spanning element that would normally be in tension, but actually here is a compression. And at that point, we started to work with some really good engineers in Los Angeles to do these digital hanging chain models for us and to start to understand the flow of forces overall, which of course influenced the way that the modules began packed together. And so this is just a little bit of description of the process, very edited, but what you see here is the gray surface, which is the surface we provided the engineers, and the pink surface came back to us. And through that subtle change in geometry, the engineers were able to modify the structure and reduce the loads by about 90%. From there, we tessellated it to have more openness and porosity where less structural performance was required, and more packing and tighter knit, closer modules where we needed the forces to be able to travel down into the columns. and then ultimately a script that would help generate those modules. We were really lucky in this particular gallery. This is a voussoir cloud at the Sci-Art Gallery, in that the gallery is not only seen from within, but it's also seen from without. And so there was a very different experience from this catwalk on the upper level, where you could see the overall form and the overall structure, versus what it was like underneath. Where here, we were the most interested in this ability of the material to become translucent at times, as well as the pattern to cast a certain kind of quality of shadow and light. And for us, the translucency was really important because this asymmetrical hypostyle hall, we did want to recall the idea of the former vaulted stonework that hypostyle halls had in, throughout history. And that sometimes the modules feel quite opaque, almost like that voussoir block, the voussoir being the stone of the arch. And because of the curved seam, almost seeming like it's in compression because of the weight, although this deformation is really more because of the geometry of the edge. And then at other times being that ultra lightweight member. And so the material itself could speak to this form and this overall structure being both compressive, but also seemingly in tension and almost ephemeral as well. And then from there, as we started moving into the building scale, I grouped this stuff with the installations because for us, these are just really like bigger scale installations. And we were, again, really interested in how to take something which is flat and through folding and geometry, allow it to have some structure. I'm not actually speaking of these fantastic pavilions by Shop, which are in the foreground and are 3D printed, but rather the parking garage in the back, which included a small little office space, the stair obviously, and then the facade. And here the material is aluminum rather than the wood, but in principle, the way that the folds work is very much the same. Of critical importance to us was that the facade felt like a mural across the face of the building and didn't seem like panels, structured individual pieces, but rather a whole across which almost literally paintbrushes would kind of take a swath over the top. This was a mock-up which showed the original structure, which had a series of verticals behind. And this is something that we really tried quite desperately to avoid. And so because of that, the form of the panel had to be self-structural a bit as well. So this starts to describe what that structure is, which is there are a set of verticals which are cantilevered from the top of the and also the bottom of the slabs, which allows for the middle panels to be free floating. They're obviously held in gravity, but also this is Miami, and so there are hurricane force winds there. And so these middle panels need to resist quite a bit of lateral load. And they're able to do that because of the folding of the pieces themselves. And then when we were digitally modeling the project, we were designating different colors just so we could keep track of apertures, what was a smaller hole versus what was a larger hole, which is important for a couple of reasons. One, just the patterning of the facade for visual effect, but also because we needed natural ventilation, which required a 20% openness for each floor overall. And so this was sort of our mathematical Excel spreadsheet in a way, color coded. And when the client saw that, they suggested, well, why don't we just think about the panels as this coloration as well? And so it's actually the process, the digital process and the modeling process, which led to the final result. Another thing that was really important to us is that the facade looked different from different angles. And so sometimes it feels quite rigorous, I would say, in terms of its diagonal lines, whereas other times it seems more sculptural and begins to really evoke the more ephemeral conditions of the sky and the clouds, of which it is also reflecting. And then much more recently, we had the opportunity to do another garage very close to our office. This was a condition where we had a lot of constraints. So in this particular case, there was an existing garage, and this was the original design for it. It's a little bit difficult to see here, but there were a series of glass panels as well as solar panels. And while they were never able to diagnose the reasons why, the glass panels were cracking, which is, of course, not what you want, because it can crack and fall and hurt someone on the sidewalk below. And so the garage stayed in the state of this really kind of unfinished structure after they removed the glass panels for almost 10 years. And so, you know, people kind of accepted that as just the final garage design. It would just not really have a facade on it so much. But more recently, the Chase Center, which is the home for the Golden State Warriors, a basketball team in the San Francisco Bay Area, was getting built across the street. And they approached the client, which is the University of California at San Francisco, which is the medical facility for the university, that they didn't necessarily want to be looking at this, what they felt like was an unfinished garage, and couldn't they do something to address that? And so we were invited into a competition, which we ultimately won, to be able to put a facade on the existing structure of this garage. Because the UCSF is a biomedical research facility, as well as a teaching facility, it was important to them and us that the facade could speak a bit to their brand and what they did. And so what we developed was a series of abstracted panels based on the DNA strand, as well as the DNA sequencing along these vertical stripes. And we use the existing horizontal rails in which to attach this vertical structure. So this was a very limited budget project. We wanted to use everything that we had there that was at our disposal. What we also wanted to do was develop some efficiency in the modularization itself. So while we wanted variation, we also didn't want to have 1,000 unique types. So what we developed was 12 types and a few halves that could each be bent at 3 different angles. And so through a mix and match of different combinations of them, we can get actually quite a large variety of paneling and angling throughout the whole facade. And this just describes just the little bit of repetition we had across the whole face, and our kind of, again, cheat sheet on how those different modules came together for building. This is a mock-up in front of our office, which again is just a few blocks away. So the panels are actually quite large, and they test the limits of the cantilever that can happen from the central spine. So the central spine was sort of a given, and how far could we stretch this panel in order for it not to literally flap around, these wings to not flap around and fly out from the building. So this describes the project looking up, and we have a series of flat panels and a series of bent panels. And what the mock-up had proved, and also which is shown in this image, is that subtle angle change really reflects the light differently, and so the facade has quite a varied appearance throughout. So again, just using something very simple like the sun to gain just different quality of the facade over the course of the day, as well as when one is walking by. There's actually a subtle diagonal pattern, which is a bit purposefully difficult to see here, but the idea is that there is some repetition, also the idea of the DNA strand traveling not just vertically, but also a little bit laterally across the whole face. This is a view from the Warriors Arena Plaza, and so it really serves as a backdrop for events, which is one of our intentions as well, that it could be something that was somewhat striking when moving by, but also could just fade into the background for those kinds of events, which happened there quite a bit pre-COVID. And we hope happen there very soon after. At the building scale, we are still very interested in material exploration and geometry. This tends to we tend to be able to do that in a more full way in some of our competition projects, because obviously we have the ability to experiment there, but it's still something that we try to bring into our built projects as well, albeit maybe in a more confined or limited way where we are able. But as our scale shift and starting to think about buildings, our concepts change as well. So while we're still interested in material exploration and use, we also are very interested in form and space. And the idea there really is something that my partner Craig Scott has been obsessed with, and therefore I am very obsessed with as well, but he's been obsessed with it over time, is the idea of the double negative. On the upper left here is the Michael Heizer piece entitled The Double Negative, which is this cut, a man-made cut going through a natural cut. But the idea overall is that how can two things come together, two voids come together to create an intersection in which is more than the sum of its parts. And that can happen, of course, at multiple scales, at the scale of sculpture, the scale of an interior, and at the scale of building. So for the Pinterest headquarters, we were able to do that in a small way at the scale of the interior. This was about 100,000 square feet or 1,000 square meters, adaptive reuse of a John Deere warehouse, a large equipment warehouse. The building was very light challenged. It had light on two sides, and then at some point in the 1980s, which we can all agree was not the high point of architecture, particularly in the United States, but they added a skylight down to the second floor. And so our first act was to bring light further into the building and cut a hole down to the first floor. And our second act was to insert a stair, which at first seems kind of counterintuitive, to cut a hole to bring light down and then put in a stair. The idea was that the stair could be a light filter as well as a vertical connector throughout the space. And that really forms the heart of the building around which all the circulation, and on the ground floor anyway, all the public functions happen. We also have a very simple installation at the front, which is this plywood waffle grid, because actually Pinterest did not lease the full building when they moved in, but the idea would be that it could really feel like a Pinterest building at the lobby, which they did own. And so this was a kind of takeover moment against the urban edge. The use of plywood was also quite important to us because Pinterest, as a company, really cares about an economy of means. And we were trying to do is use humble materials in a new way. And so this describes the lobby and looking towards a front cafe piece, where we also did some really simple mobile furniture and the barista. And then that is adjacent to what they call the all hands space or the large dining area. And then you're starting to see the stair in the distance here. And really our work, I believe, had to do with, again, how to bring in light in multiple ways, whether it was through subtle shifting of material, whether it was through just a simple array of fixtures that could define one space apart from another, whether it was through the glowing coffers of the plywood entry, or through the stair itself. And for the stair, it is a steel structure, which is supported on a platform and then partially hung as well. And so while quite heavy, of course, our intention was that it could feel like it was also floating in the space. And then around the stair are, again, all of the shared public functions, which include the servery, the all hands, the servery here, and the stair forms that centerpiece around which people revolve. And so there's a natural circulation path that starts to emerge around it. And at the same time, the stair was a vertical connector and a visual connector as well. And so tech offices had their home here in the Bay Area in Silicon Valley. Silicon Valley is not so much a city as it is a suburb and what we would call an edge city here. And in other words, it's very spread out. And the buildings were also very spread out. They tend to be 1 to 2 stories. They have a really, really big footprint. And that was really conducive to the kind of collaboration and teamwork that was really critical to tech innovation, and still is. But as tech offices started making more of a commitment to the city, they were forced to move into slightly smaller footprints and taller buildings. And so the idea of how to communicate across levels was of critical importance. And so the stair is, in a way, a symbol of the vertical communication between these two levels, the public level and the work levels. But it's also a visual connector. And we just did that very simply by, inserting large apertures that kind of would focus a view almost like a lens from one level to another. And then the stair itself is hung, as I had mentioned, from the floor above. And so it's allowed to float and provides seating areas and other small informal congregation spaces around its edges. And then the stair is made of a laminated perforated, and that was important to us because we were able to include just light inside to have it illuminated. We did a lot of tests because at one point it was a moray and everyone we were fearing would be dizzy moving up and down. So we ended up with a very tight perforation on the inside, so it felt more solid, and a much looser perforation on the outside, so that one could see this more like a skeleton. And this was Pinterest, again, pre-COVID, kind of at full swing, with the stair again acting as that heart and that lantern in the middle of the building. There's also a story behind the stair, which again taps into Pinterest brand. One of the words that they use a lot in their company is that of knitting. And the idea of knitting is about collaboration, and it's about cross-functional teams. But we took it quite literally, the idea of knitting, bringing two things together to form a third. And that third was actually a void space in the middle of the needles, which again is quite critical to build the actual sweater or the scarf or what have you. And so the stair is like the two halves of the needle, which self-intersects, and that intersection forms a double negative of the stair itself. This is a view from above in the 1980s atrium, which we did very little to other than paint it and add some plants. But when looking through the stair, there's actually this transparent moment, this prism, which is that double negative aspect of knitting. And so as Pinterest employees bring the visitors and the many, many partners they have through, it becomes a small story for them to speak to knitting and how that's really important to the company culture, embodied abstractly in the volume of the stair itself. The stair is really big, much bigger than it needs to be. So it forms a kind of, again, a place for other people to have conversations and to even congregate sometimes. And it really has become the heart of that building. This is the double negative intersection from below. And this is it from above, where it forms this glass prism. And then the stair kind of rises up on the second level, a little bit like an animal, again, to capture the light from above and then to form the circulation around. For the rest of the space, we thought of the floor plan almost like a mini urbanism, if you will. And so that's where some of our speculative work we felt came in handy, because this was the first project we did of this scale. I mean, period. We had done like 2 interiors before this. They were both quite small. And so thinking about this, the floor plan as a kind of mini urbanism, it was just a series of volumes. So we were much more interested in using volumes as a way of creating blocks and neighborhoods and streets and alleys than we were about walls as subdividers and separators of space. And so we have a series of volumes which separate and connect the more social and louder center with a quieter perimeter for heads down workspace. And the volumes take on different characters, sometimes being quite transparent and other times being semi-transparent. We had a series of color-coded curtains as well that acted as a kind of intuitive wayfinding device, because it is a fairly large floor plate and a little bit sometimes potentially confusing. And the other thing we developed was a glass corner, and that glass corner enabled us to have these see-through moments, these peekaboo moments from open space to open space or from closed space to closed space. And it was the idea, again, of knitting as the metaphor, that visual metaphor that would allow these intersections to happen through a void rather than through a solid. And also to deal with any kind of FOMO that any of the employees were having, because, while they're moving around this large building and doing different things, they also do want to be found in case a team member or someone wants to come up to pull them into a conversation or into another meeting. And so this just shows, kind of the quality of the meeting room, which is never fully enclosed, but always partially open to another meeting room or an open space. And that project led us to the second Pinterest headquarters project, which was slightly larger, was 150,000 square feet. And interestingly, we started designing it before the first headquarters was finished. So We started with Pinterest and there were about 200 employees. And before the previous project that I just showed, we were able to interview about a quarter of the company, which was 50 people at the time. By the time we started designing the second headquarters, they were, 700 people. And by the time they moved in, they were, 1,500 people. And so just rapid expansion of the tech company. So we weren't able really to do a post-mortem on the first project to see what worked and what didn't work. But one thing that did become clear is that Pinterest had evolved their kind of aesthetic sensibility. And so where we spoke first about plywood being that humble material used in, trying to use it in an innovative way for the first headquarters, they were very interested in being a site about creativity rather than craftiness. And so I think when early days of Pinterest, it was about knitting and people putting their little DIY projects up for others to share. But now it's really just a platform for inspiration, and it's much broader and in a sense more powerful. And it's about creativity in a much broader way. And so we started to look at slightly more refined materials, but still wanting to use them in a slightly different way. So this is the lobby of Pinterest, which is actually also a public space. So while owned by the building, it's open for anyone to use during all working hours. And that's a San Francisco mandate, and mandated for this building as well as mandated throughout the city. And it forms a really nice network of these public spaces within buildings. And Pinterest was really excited about this opportunity. Even though they're taking care of the space, they were excited about bringing in the public and having people there who could share their work with them in a way. So what they did is they chose to open a cafe, and there's a full, we developed a full kitchen in the basement, and they would run this cafe. And so the cafe becomes part of the lobby, not really closed off, but fully open. And it does form that intersection between the public and the Pinterest employees. We feel like in a really wonderful way. And so the lobby is, very reconfigurable. It has seating, it has tables, it has small spaces for the employees to use as an extended workplace, but it's also a place for anyone from the public to come in. That said, we of course needed to separate out the work of Pinterest across a security line and what they did, with their day-to-day operations from the public. So the public cannot wander through the entire offices, of course. But we did want to have, another kind of intersection among the populations, and we did that through this cascading stair, which switchbacks over the lobby and hangs suspended above the lobby. And so people moving through their daily routine within Pinterest would have a constant overlap with this public shared space up above. This is entering through the security zone, and there's also an internal street which leads to the back alley. And so again, just thinking about how this building can function also like a kind of neighborhood or a smaller urbanistic moment. As well, this is where the public functions, like the multi-purpose room, a breakout area, a library study area would happen off of this spine. And it was also an opportunity for us to insert an installation. This is made out of an insect screen mesh. And so we still, again, while we're not building the whole building, we're still able to work on installations within some of these buildings. Pinterest being the perfect example, because they, of course, are about unleashing people's, creative spirit and be able to make something yourself. So while we didn't make this entire ceiling ourselves, we did mock it up. And again, really didn't use any digital modeling for it, really. We just got some rectangular cloth and tried to see through how, through literally using push pins and nails and how it could take on different geometries, and ultimately ended up with this kind of folded parallelogram form. This also serves as a light baffle for the room, as well as shielding the acoustic spray, which is above. And so it's a multifunctioning surface, even though really what we were most interested in is thinking about how to make a volumetric surface in this relatively short floor-to-floor height. This is an entry, this is the rear entry, looking the other way down that internal street. And then moving up the stair becomes more like an object in the different rooms, and a intermittent connector across the floors. This is the all hands space. Again, this had a much more limited floor to floor height. And so what we worked to do was really compress, for example, the typical acoustical sandwich, which often takes 18 inches. Here we compressed it into, like 6 inches. And in doing so, developed some integrated lighting, which could be both embedded and float free from that acoustical surface and take on different geometries along the different sides. And this again serves as their all hands space or lecture hall, as well as their dining hall. This is a stair that cantilevers out over the public space. And then the switchback moment, I'm also describing how it kind of shoots its entire way through the building. So again, this was sponsored by just the desire to communicate across the different horizontal levels and have a really clear passageway through the building. Very different from your typical switchback stair. And this is, taken right before the building was fully occupied, but it really, again, pre-COVID was really like a freeway. People moving up and down, particularly during lunch hours and, kind of areas of high traffic. But just the idea of seeing where you're going just instigated so much more movement through the space. And the stair itself is clad with metal rods. So initially, actually, we thought, well, here's a moment for us to use plywood. Plywood is something we could take from the original building, and it's almost like a nod to where Pinterest came from and part of its earlier evolution, and have plywood wrap the stair. Ultimately, it was something that the founder, Evan Sharp, who has an architecture background before he started Pinterest, was not interested in. And by the way, an amazing client to have is someone who has studied architecture. But anyway, so when we were starting to rethink it, it also turned out that the stair itself was so overstructured because of the plywood, and plywood is a rigid material. In the building, we're in seismic earthquake country, which the building's going to move around a lot, and the stair had to be so overstructured in order for the plywood not to crack. And so we chose to work with a material that has much more ductility, which is steel, and use it as the guardrail as well as its enclosure. And so the stair can move around really as much as it wants without it being damaged in any way. The other decision and impact of the stair is that the stair itself is actually the kind of most simple, straightforward stair one can have. It's a metal pan with a concrete infill. And we did that because we were designing as the building was already in construction. So we kind of chased them up the building. And so there were certain decisions that had to be made for the base building to be completed, like where's your stair going? What does it look like? And so we said the stair is going here, and it's going to look like your most average fire stair you'd ever seen. But what we're going to do is design a volume around it to shape it. So it's actually an incredibly boring stair, just wrapped by these then, kind of somewhat flexible metal rods. And then around the stair itself are a series of rooms again. And here, wanting to celebrate the corner just in a slightly different way with an integrated door to wood panel, which sometimes becomes transparent and other times becomes opaque. And then looking down, one is connected again. This is from the top floor of the building, the 6th floor, back to the street edge. And so just bringing the life of the street and the idea of the street all the way through the building through this one element. Moving on to a full building, this is the Godo residence, which is in Napa Valley. And so here, even though it's a very small building, it's only 2,000 square feet, 200 square meters. We were able to think a little bit more about, what does it mean for us to design a building in the round? And again, being in San Francisco, which is a very dense urban place, we're actually not often able to design whole buildings in the round. Even office towers and things like that in the city are often hemmed in on two sides by other buildings and a zero kind of lot line condition. And so we were really excited to be able to pursue this project. The project itself is sited on 95 acres, so a really big piece of land in the wine country, but not really so much in the wine country valley, more on the other side of the hill, which overlooks a beautiful lake, Lake Berryessa. And so clearly, looking out to the lake is a really beautiful view. But even looking every direction on this site, there's something kind of different that it offers. There's a quiet side. There's a side that just feels a little bit more tame with like rolling hills. And there's a side that feels more foresty with the larger mountain behind and the bigger trees. And so we really wanted to think about what does it mean, to do a building in the round. And this is a building cited right here. The house is completely off the grid. It gets its water on site through a creek, which we then tap to fill cisterns, and it's run fully off solar power. And so the garage, which is also a very simple building that we designed, acts as kind of the battery for the house with the solar panels, and then you're not seeing this, but the water tanks are behind. And then we just trench it through into the house. And so again, completely self-sustaining as a piece of property. And then there's a very small pool, which is part of the house. Interestingly, I put this in here. This is actually a module from the Miami Design Garage. And clearly we didn't even realize it at the time until later. But we realized that, it has a very similar idea, which is a 6-sided figure transforming into a 4-sided figure. And then just doing that in a slightly different way for the house than we did for the garage module, obviously at a really different scale. So the idea for the house is to take this asymmetrical hexagon and while it's very outward looking to the views all the way around the site, we also wanted to think about a quiet moment. So also very inward looking with this rhombus courtyard. And then the site is actually heaving soils, meaning they're very unstable soils. And in the beginning, the site was structured, the building was structured with these deep piers that would go down, like typical piers do, down to more stable soil, which meant that our building was kind of sitting up on these little piers, at which time it felt very grounded, I would say. And it wasn't quite in keeping with our intention for the house, which is that while very locally manifest through the views, we didn't actually necessarily want to create a house that felt like it was born from the site, but rather something that could hover between being an imported object, as well as being very site responsive. So through the heaving soil discussion, we worked with a structural engineer to actually make a mat foundation, at which point the building kind of became a slab on grade, which is also something we didn't really want. And so Craig, my partner, woke up one day and he said, "Oh, I dreamt the solution to the Godot house." And I was like, "Oh, great," because I really hate the foundation now and I couldn't come up with a better solution. He goes, "Yeah, we're going to cantilever it." And so the building is cantilevered off the base, and it kind of acts like a boat in the water on these heaving soils. And at the same time, we've sloped the roof in to again, capture the little rainwater that does come to the roof to a gutter, which wraps around the exterior of the courtyard. And then there's a series of other porches which are carved in to take advantage of those views, actually constructed largely through the view angles as this, in between inside outside space in order to look at the different sides of the site. So while asymmetrical as an overall geometry, the rooms themselves are actually really straightforward. They're just a series of rectangles, very easy to furnish, and relatively straightforward to build, therefore. So there's the kitchen and dining room, a kind of study or yoga studio, another set of kids' bedrooms, and then the master. And those all pivot around the central courtyard. The sections that just begin to describe a little bit the cantilevering of the foundation, as well as a tapering of the roof towards the courtyard. So very simple shed-like interiors in each of the rooms, and a view from above, looking out to the lake, as well as a small bit of landscaping between the house and the pool. And then just some views tracking around the exterior, just to try to describe a little bit of that hovering volume. And just the way the house changes actually quite a bit as one moves around it, and also through the times of day. So the porches take on really pretty different geometries, even though they were conceived in very much the same way. This is the entry drive. Again, a very small house. This is a second home for the client, not a primary home, so used predominantly on the weekends. And then a very simple set of stairs which leads up to, kind of cover the space of the elevated building from the cantilever, which is also cantilevered itself. So just not touching the building, but almost touching the building. And then it was a decision to, kind of have this outer metal jacket, but a softer wooden porch, because that's where the clients are really occupying. And the wood would work better in that location too, just because it could be protected. And then moving into the house, the rhombus courtyard, which is a kind of abstracted volume, this prism in the middle of the house, again, to bring light in, but also to structure circulation. Then the series of porch doors, which travel around as one travels around the courtyard. And in visiting it, what I, during construction and a little bit after, what I particularly enjoyed is just some of the frame views that would make. And this is a view from the back. So against the courtyard, there's actually a poche piece. This is a closet. And inside this closet is basically the brain of the house. That's where all the infrastructure from the garage comes. And this is where all the panels and the controls for the solar and water are housed. Just moving around again. And then just really different views looking out to the different sides of the landscape. These photographs were not taken at really too dissimilar of a time, but the light quality as a whole is so dramatically different. And then on the interior, a pretty simple and sturdy interior, a concrete floor, relatively open. Our client was an electrical engineer. He had worked at Apple, and so we developed just a really simple ceiling and an integrated light, and he actually spec'd all the light fixtures for us, which is really fantastic. And just some more views, just understanding the building as a whole. So while quite simple and rectilinear, again, those volumes actually have a more dynamic character because of their relationship to each other around the central courtyard. And then a view looking out to the larger site. We also thought about the lighting as being able to structure kind of the movement of the building or reinforce the geometry of the building, which we did around the inner courtyard, as well as the outside perimeter. And then moving up in scale again, this is a project that we're currently working on. It's in construction, meaning it's a huge hole in the ground right now. So it'll take a number of years to build, but we've been working on this project for 5 years. And so this is maybe a symptom of San Francisco, which is just, it takes you forever to get approval from the planning department in the city. And because of that, we had a number of iterations. We have a number of iterations anyway, though, because we love to study just the volumetric character, obviously, of the buildings. And the idea with this one is that it was really two halves that came together around a central connector. And so while it's one building, the idea is that it could really act and look like two buildings, because being a very large site, and this red outline describes the site as a whole, there wasn't really a real estate use necessarily for such a big site. And so the idea would be that the building could be divided into two tenants or just multi-tenants, and that the building would have different characters throughout. And that was also mandated by the planning department, which I'm going to show in a minute. But in any case, one of the interesting things about the site is that it took over the place of these 24 tennis courts, 12 inside and 12 outside. And it was a mandate from the tennis club who operated the building that 12 tennis courts fit inside our building. So they actually fit in the basement of the project, which serves to connect the underground together, which of course affects the structure. And so we were working with a series of constraints for the project. One was the structure coming from having these underground tennis courts. Another one was the setback limits of the city, which they call the sky plane, which seems like it should be quite flexible, but actually if you follow it rigorously, it pretty much leads to the wedding cake. And that is something that we wanted to work with, but also avoid the aesthetics associated with it. And then lastly, the idea that the city was interested in speaking to the character of what the history of this site used to be, which was kind of two predominant things. One were these kind of masonry buildings, and they asked specifically for masonry, that the buildings have kind of masonry-like or cementitious quality to them. And the other, this more kind of industrial sash. Both of them were the warehouse type. And so we decided that rather than having a single building that looked like one big building, that we would embrace this desire and have the building appear as actually two very different buildings. And because we didn't necessarily want to also just have two different facades on the same massing, what we chose to do is have two different massings that could both work together with the idea of the sky plane around just, you know, a more central transparent spine. And so the West Tower becomes a series of these like kind of pixelated blocks. And the West Tower becomes a series of these sliding shifted massing, and the more to celebrate more of the horizontal. That is what is described here. And then an earlier rendering of the way that those facades started to develop, excuse me, around the two different towers. The Western Tower with the pixelated, more rectilinear volumes, taking up the challenge of the more punched kind of cementitious facade. And then the Eastern Tower, which is more a series of these shifted and sliding horizontal volumes, taking up the idea of the industrial sash, more like a veil across the front of the building. This is a view from street level, just looking at, you know, just again, our desire. And so here, just in a different way, but our desire to take something which is maybe more often two-dimensional, such as the skin of the building and the facade, and creating some three-dimensionality out of it. Again, just through the geometry of the window, and how those two come together across a center spine. And then for the veil-like building, we're using terracotta, a sculpted terracotta, to form these vertical ribbons that again add that dimensionality, depth, and also shadow to the edges. And so this is just a more current rendering of the project as it stands now. Both facades take up an attitude as well of having some variation to the different facade panelization types. And the idea here was really, so there's actually a kind of natural podium level in this formerly historic fabric. And what the planning department initially asked for is the idea that the bottom is looks like an old building, or, you know, has more of the proportions of an older building with a glass tower on top. And we were actually interested in not doing that, and how to think about distributing either the idea of the punch or the idea of the industrial sash up the building, so that we could unify the top and the bottom together, but that also we could have some differentiation. And the way we chose to do that is to have a bit of a gradient. And I'll just describe that process just a little bit for the Western Tower, which is what we did is we developed kind of a bounding envelope, a bounding box, around which we could develop how these gradients would perform, not just to have variation for variation's sake, but also to get more light in on the northern side of the building, and also where the building footprint was the fattest, which is at the bottom, and less light on this, you know, a little bit smaller aperture to assist with the solar heat gain, and then again greater aperture on the north where we had the views to downtown. And so that bounding box was then projected onto the massing of the building itself, and that began to dictate the different porosities and openings of the independent modules. And so we don't actually have that many module types. We have 4 basic types and then a collection of other types to deal with corners and things like that, and that is arrayed around the building as a whole. And then we had a similar exercise, which I won't show here, but for the Eastern facades, which just have a change in transparency from wider terracotta panels to thinner terracotta panels along some of those same principles. And so just starts to describe what that those variations start to look like for the different pieces, as well as the whole. And again, the overall intention, very much like our other projects like the Miami Design Garage and whatnot, is that the building would change as one moves around it. And so the Western facade, for example, has a cementitious material for the large window cuts, but for the smaller frames and on the edges has a copper color material. And so when one looks at the building from one way, it appears as one kind of facade material, and when one looks from the other way, it has the other. And a view from the project overall. And then more recently, currently, we were awarded a commission for, we call it like a campus in a building. And this is for Ivy Tech Community College, which is in Columbus, Indiana. And for those of you who probably don't know, Columbus, Indiana, which is you know, in the Midwest, and one doesn't normally think of the Midwest as the bastion for excellent modern architecture, Columbus, Indiana actually is a mecca for modern architecture, because in the earlier part of the mid-century, a corporation called the Cummins Diesel Engine Foundation, or Diesel Engine Company, worked very closely with architects like Elian Aero Saarinen and Kevin Roche to design their buildings for them. And as huge fans and buffs of modern architecture, they developed a foundation so that they would be able to support great design in Columbus. And it's a kind of place where you can go to the local pharmacy and have a half-an-hour-long conversation, which is what we did about modern architecture when we were trying to buy sinus medication because we got a cold when we were there. You know, so it's just like this incredible community and a very architecturally knowledgeable community. So our commission was sponsored by the Cummins Foundation for a new school. So they would sponsor the design for public or other kind of civic programs. And this is for a community college called Ivy Tech, located in the northern part of Columbus. So the colored part is Columbus, and the real center is further south. But this small campus is located next to the regional airport, and so it's called the Air Park campus. And they hadn't had a commission to the Cummins Foundation for a really long time. The city hadn't for a really long time. This was one of the first, and so we were just so honored and delighted to be able to work on it. It's an interesting project in that it's a replacement building. So this is currently where Ivy Tech is. And it's part of a larger campus which involves Indiana University and Purdue University, as well as an advanced manufacturing center and a learning center for the city of Columbus, where the different universities and colleges have shared programs. And so while a bit dispersed at the moment, especially because of the placement of the Ivy Tech Columbus building, the idea is that these buildings together do form a campus, and Ivy Tech building, which is the only building that they fully own on the campus, is actually all of their programs under this one roof. So because this is a replacement building, the buildable area needs to work around the existing building. And the idea would be that the building could actually create that quad. So the current building, you could be in there for, which we were, about 6 hours one day and didn't even realize a quad was there, because you enter off of the central road more to the south side. And so after the new building is built, the old building will be demolished. And so there were a couple, kind of primary concerns around how to create this campus. One, which, was a no-brainer, was actually given to us, is let's put the building on the quad to actually make the quad, which just makes all kinds of sense. Some additional parking, of course, and then to have a kind of gateway from the Central Ave view, where one could look through and actually have a vision of not just Ivy Tech, but the shared quad among these different universities, by being able to see the quad from the main road into the campus. And so that's what really shaped our design. We had a really fun experience, a challenging experience, but an exciting experience too, where they had all the architects. There were 5 shortlisted, and we each went out one day between a Monday and a Friday. And this was the week before Thanksgiving. So we went first. We went on the Monday, where we got to see the site, and we got to hear more about the program. We got to meet, some of the stakeholders of the project. And then Craig and I were both sick, which is why we were at the Walgreens getting our sinus medication and talking to the clerk there. But at the very end of the interview, or not the interview, but the site visit, Craig asked, "So are you guys looking for any design ideas when we come back?" I think we were going back a week after Thanksgiving. So we only had about 2.5 weeks between this first visit and the second one. And they said, yeah, we would like to see some design ideas. And we had our Thanksgiving holiday in between. So we went back to the office and said, okay, team, we have to design some buildings or come up with some concepts in about a week when we get back from vacation. And so we just kind of threw the whole office at it and came up with 3 different design ideas. None of these ideas got executed. We didn't have a budget at this time. We didn't know the full program. But really our intention was to show the way we work and how we think. And so this is what we presented in our interview. In any case, the building is dramatically different from all of that now. When we were awarded the commission and sat down, they had their full team in place. They had an executive architect who was fabulous, CSO. They had the contractor who was very budget conscious. And because this is a public building, it could not go $1 over the allocated budget. And so one of the first things that we learned is, your building should really be just a rectangle. And it almost is. But we still wanted to respect the things at the site, which is to have that view, the gateway view from the entry road, obviously to place the building against the quad. And because it is against the quad, which is limited in width, it becomes a very fat building once it includes all the program. The other aspect is the building is essentially the exact square footage of the old building, which is another mandate, although the programs within shifted around quite a bit. So we began with a box. And the idea is, okay, we have this box, this rectangular volume, but perhaps we can make just a few architectural moves to really enhance the site. One being from the park and be able to see through from where you're parking to the quad, which is not something you could do in the existing building. And the other one is to rotate that volume so that we might have one small portion which is not within the orthogonal, but actually just shifts to allow for a covered entryway, an opening up of the central internal street, the spine that we have, looking out to the quad, and then a small area in the front which will act as the student commons. That actually shaped the building as a whole, where all the programs are then nested in between. And there's a number of stakeholders in this project. There's a number of different programs. They have 20-some different kinds of offerings and degrees you can get, including health sciences and nursing and visual communications and business. And it's just internet technology. It's just a really vast range. The idea would be that these programs could then come together around what we call the social spine, as well as the student commons and this pathway through the project. This is kind of another roof off bird's eye view, which starts to describe how that social spine works, and then some of the secondary circulation that happens off of it. And then, repeated on the second floor with a stair which connects the two together. And a small terrace over and above that rotated volume, which could then overlook the quad as well as the Columbus Learning Center. And then it was really important for us to have this central spine be skylit. We initially started with a series of much more dramatic skylights, but again, that was quite expensive and not very, it didn't fit within the budget. And so what we chose to do is something really simple, which is a very standard way of bringing light into a building, which is having a clerestory, and just simply having the clerestories face south, west, and east. And so the light and the time of day can still be registered in the space. This is a view from above, what that building looks like against the quad and the adjacent buildings and campus buildings forming that quad element. The front elevation. And here we wanted to work again. So one of the first things we asked after we were informed that, a rectangle is really the best building form, we asked, well, what's the best building material in order to, maximize just the cost efficiency of it and for that region? And they said brick. And that was exciting to us because out in San Francisco, we don't do much brick because brick is not a very earthquake-friendly material. And so we chose a white brick for the majority of the building, and then just a simple metal box which rotates out of it. This is traveling around to the east. And one of the things we were interested in, again, is how do we think of brick and just do something very subtle, which is the corbelling at some of the windows. We had, a lot more initially, but through kind of value engineering, just really wanting to put it where it made the most sense, to create some three-dimensionality and shadows on the facade. And this is a quad view with the student commons against the quad, which then relates directly to the other campus buildings across that space. A bit more of the three-dimensional views describing the corbelling, as well as the way the glass and just the materials play out through the whole. So just a simple and volumetric in character, but we feel actually quite diverse in terms of the space that one gets on the interior and the quality that we're working to achieve with this very simple corbelling at the windows with the white brick. And so this is I'll just do a really quick walkthrough and then show a short animation. But again, that rotated volume cants in to form the covered entry, which is a kind of larger expression, I suppose, of what we're thinking of our canted windows at the corbelling. And a few other moments of that in and around the building. Moving into the reception, which is intentionally compressed, and then moving out to the social spine. And so some of the geometries, we only have two geometries in the building really, one that responds to the rotated volume and the other which responds to the orthogonal. And to get together, those form the kind of volumetric character of the central spine. There's also an aviation program, which is kind of a highlight because they do teach you how to fly, and again, the Air Park campus. And moving through to the community room and the social commons, and then looking back, kind of a wide angle view with the commons, and then a cascade stair. So a cascade stair was actually created in one of our really initial studies. And so while the building changed a lot, that is actually something we were able to carry forward into the scheme. So forming just a series of smaller study spaces overall. They have this excellent graphics communication department, just to go back one. And so just the walls of the building here shown really white. They're actually owners of the RAND collection, which is an incredible, graphics and illustration collection, which will be able to be on display through the building. And this is looking down the cascade stair. And then just a view from that second floor circulation, which wraps around. And then again, similar and dissimilar from Pinterest with color, just using color. And then these are the secondary colors of Ivy Tech's brand colors, complements of that, using them in a way that one can just begin to locate themselves in the program because of the color of the hallway, which is, again, we're trying to use quite volumetrically. And so this is just a short animation which describes the so moving in from the parking along that diagonal. Under the canopy, into reception. Using really limited wood, but in places where we felt like it made the most sense. Happy music. This is the express enrollment, so actually a number of what are currently more contained programs started to move out to the social spine as well. And the student commons against the quad. The spine is actually the only place where we have ceiling material. Everywhere else is just the raw exposed structure and metal deck. And then moving up the cascade stair, steady notes. And then down into the corridors. And here, just wanting to use a real economy of means. So, just not painting and leaving white for the entries to the classrooms, just so that, the door of the hallway actually becomes a bit more celebrated. And these other, some of these are other kind of back of house doors. And then really simple, just linear light fixture to illuminate that space. Again, a raw ceiling virtually everywhere except in that central social spine. An overlook to the social commons. And moving down and out to the terrace. There's actually another stair that connects back down to the social spine with an overlook, a smaller overlook, and then this is outside to the terrace. And then just different degrees of corbelling, some larger at the terrace door, some smaller at the windows, and some larger again in the middle, which is really the expression of the social spine and a reflection of that rotated volume on the first floor, translating through the building to the second floor and connecting that heart of the building with the heart of the campus, which is the quad. Okay. This is the site currently, meaning it's in demo, which is really exciting for us. And should be completed construction next year. All right, so I have 2 projects to show for the speculative work. And, the speculative work for us was really, again, just a way of working on things that we didn't normally, weren't able to work on. Sometimes they were competitions and sometimes they were commissions by museums. And oftentimes, when commissioned by museums, it was about looking at an architecture for the future, sometimes a near future and sometimes a distant future. Also a chance for us to, at this time, so some of these projects were done a number of years ago now, but experiment with digital processes that, we maybe didn't have a chance to do or just trying to learn, frankly, at the time. So that is what we had done, and we had done that for a number of these projects, and one of those projects is the Jellyfish House, which I'm not going to talk about here, but did lead to a project. Thank you.
Thank you. Thank you very much, Lisa. It was really a fascinating and stimulating presentation of ideas, speculations, and built consequences. Thank you very much. In closing, I want to thank our Dean, Professor Julie Willis, for her introduction and support for the Dean's Lecture Series. I want to thank, as always, the excellent promotion, management, and logistical support from the events, exhibition, and marketing team while we still have them with us. And I want to pay particular attention to the Advanced Digital Design plus Fabrication Research Hub, or ADD plus ELF, in initiating and developing this extended relationship with Lisa Iwamoto. In particular, I note the hosting role of Dr. Sofia Colabella and Dr. Alberto Pagnale in dealing with the myriad details necessary to make this lecture and the following engagements we will have with Lisa a success and a contribution to our teaching, our research, and our expanded network. The Dean's Lecture Series is not a single lecture, but rather a series of engagement, conversations, seminars over a few days or even a few weeks. Some of these may be recorded and available on our YouTube channel in the future, and we really sincerely thank Lisa for her participation now and in the coming weeks. Finally, I want to thank our audience for joining us and for continuing to engage with our MSD at Home presentations and the Dean's Lecture Series. On behalf of the Faculty of Architecture, Building and Planning and the Melbourne School of Design, thank you and good day. Thank you, everyone.